Net zero emissions by 2050 has become a global consensus. The latest 2022 report from the IPCC indicates that to maintain less than 1.5 degrees Celsius change in temperature by the end of the century, we will need to implement a plan to reduce global GHG emissions by 43% before 2030. The priority is to increase use of clean renewables and reduce carbon emissions during industrial manufacturing. The development of renewable energy is an important lesson for the current policymakers of many nations. Technology has matured and installation costs have decreased in recent years. The proportion of solar energy has also risen alongside growing needs. But due to limits in the product lifespan, an estimated 100 million tons of solar panel waste will be created globally by 2050. Without adequate treatment, these devices pose a serious threat to our environment. Industrial Technology Research Institute proposes two major solutions to recycle solar modules and reduce carbon emissions. 1. Highly efficient PV recycling. In traditional solar panel recycling, only the aluminum frame can be fully disassembled. The remaining components are bound with thermoset materials and are mostly crushed, sorted, and then recycled. But high levels of impurities and low separation rate makes the recycling process difficult and costly. Manufacturing 1 gigawatt of traditional solar modules emits 740,000 tons of carbon. Crushing the materials for recycling yields only 53,000 tons of carbon worth $16.5 million. The efficiency of recycling is extremely low. ITRI's high-efficiency PV recycling system provides a removable frame and back sheet separator for full recycling of the glass, frame, junction box, and back sheet. Also, it is more weather-resistant, reduces waste, and increases reusability, reclaiming 142,000 tons of carbon emissions, for a total value of nearly $37.5 million. Recycling efficiency is almost tripled compared to traditional modules. 2. Redesigned PV modules for easy dismantled. The newly developed composite encapsulated film is made with thermoplastics and thermoset film, which are easy to disassemble and have high shock and water resistance. Not only does it maintain efficiency when generating power, but it's integrated into the module manufacturing process. During pyrolysis, all materials can be separated without having to be crushed first. Solar cells are kept intact and fully recycled into reclaimed silicon wafers or solar cells, giving new life to old, decommissioned materials. This greatly reduces the energy and water consumption and carbon emissions during the manufacturing process. It is estimated to reduce carbon emissions by 50% when compared to making a brand new PV module, creating only 340,000 tons of carbon emissions. It can recycle up to 34,000 tons of carbon emissions. And the value of recycled materials can reach $70 million. As the world strives towards net zero emissions, we need to change the foundation of how we manufacture and use products. The circular economy provides a new mode of operation, where we reduce sourcing, recycle, and reuse resources. ITRI starts with the first step, reduce sourcing, allowing components of new modules to be fully reused and recycled. Not only does this reduce use of raw materials, it also preserves the value of the product and materials, and develops a sustainable business model by closing the loop. Enhancing capabilities while reducing carbon is a key strategy in the march towards net zero emissions.